So, when are we getting married?
That's a question even science hasn't been able to answer.
Excuse me?
I'm kidding, love. You know how scientists are. I've actually been working on a theory lately. If it turns out to be right, it'll change how we see the entire universe.
Really? What theory, though?
Not sure yet. I'm just waiting for the revelation to hit me. Ow! What is this, like an apple?
Go on, Newton. Keep going. What were you saying?
Right, I was saying I'm waiting for a sign. Something to point me toward. Ow! Is this tree broken or something?
Newton, it's a tree dropping fruit. Anyway, back to the actual topic. Did you get the ring?
Oh, right, the ring. Actually, I wanted to talk to you about that. Don't you think rings are a bit old-fashioned?
Excuse me?
I mean, for example, ow! Wait a second, why didn't I notice this before?
Notice what?
Every single time I try to talk about marriage, an apple falls on me.
And what does that mean?
It means that there's a hidden force, something pulling the apple straight down.
A force? What kind of force?
This particular force is the power of jealousy. Let me tell you about a very cold night. Back in the winter of 1642, at a small farmhouse in Lincolnshire, England, something is about to happen that will change the entire course of human history. Something that isn't even supposed to happen yet. It's not due for another 3 months. A scream fills the house. Women rush in and out with hot water. Someone's yelling for the doctor, who is, of course, running late. After hours of pain, the hero of our story finally arrives. A baby with almost no chance of survival because he is so small, so unbelievably small, that his own mother later said she could have fit him inside a teacup. Nobody expected this child to live. He lived. And he grew up to become the reason physics teachers everywhere would eventually ruin your Tuesday afternoons. Isaac Newton, born into a simple family. His father, a farmer, died 3 months before he was even born. So his mother decided to name the baby after him, Isaac. His mother stayed with him for the first 3 years of his life. Then she remarried a wealthy man, moved away with her new husband, and left little Isaac behind with his grandmother. This, my friend, messed with him. It's part of why Newton grew up leaning hard into isolation, and some historians think it's the reason he never got married in his entire life. When Newton turned 19, he wrote a private list of his own sins, the way people did back then. One of them, that he had once gotten furious at his mother and stepfather and threatened to burn them alive in their house. 19 years old and already planning arson against his own family? Yeah, and that wasn't even close to the worst thing on the list. That was one item out of nearly 50. While living with his grandmother, an uncle noticed something in the kid. Curiosity that didn't match his age. Instead of playing outside with other children, Newton built tiny working windmills powered by mice running on wheels inside them. A slightly unsettling child, honestly, but a genius one. He wasn't just inventing things. Sometimes he was inventing the tools needed to build the inventions in the first place. His grandmother eventually sent him off to school. There, he ended up living with a local pharmacist for a few years, and it was there that Newton first fell in love with chemistry, learning how to mix medicines and herbs. You'd expect the school reports to say, future genius, obviously. They actually said the opposite. Distracted, inattentive, not particularly promising, so his mother pulled him out of school completely. Who are you going to become anyway? Someone who changes the course of history? No. Go find real work. Learn to farm like your father did. Or better yet, we just inherited some property from your stepfather. Go manage it. So Isaac Newton, future father of modern physics, was seriously considered for a career as a landlord. Great location, motivated seller. Thankfully for science, he was terrible at both farming and real estate. An uncle stepped in, convinced his mother to send him back to school, and this time, Newton lived with the headmaster himself. He went from distracted kid to genuinely gifted student. And by 18, his family finally agreed to send him to university. In 1661, Newton enrolled at Trinity College, Cambridge. Now, Cambridge in the 1660s wasn't the legendary institution we picture today. It was still officially teaching ancient philosophy, the idea that the Earth sat at the exact center of the universe, even while newer scientists like Kepler and Galileo were proving otherwise elsewhere in Europe. This drove Newton up the wall, so he did what he'd keep doing for the rest of his life: ignored the official curriculum entirely and taught himself physics and mathematics on his own time, mostly from an old geometry textbook because his formal math education wasn't strong enough yet to keep up with what he wanted to understand. And then, mid-degree, the world stopped. A plague swept across Europe. It killed roughly a third of the population. In some cities, death tolls hit 80%. Sound familiar? Cambridge shut its doors, and Newton, like everyone else, got sent home. You'd think that wrecked his momentum. It's actually the opposite. Stuck on the family farm with no lectures, no deadlines, nothing but time on his hands, Newton entered what historians now call his wonderful years. Instead of baking sourdough and doom-scrolling, he changed science forever. And this is where the most famous scene in his entire life supposedly happens. An apple falls. There's no reliable historical record proving an apple actually smacked him in the head. Most likely that detail got added later by writers who wanted a better story. What we do know, from notes taken by a friend who interviewed Newton late in his life, is that an apple did fall in front of him, and it got him thinking. Not about the pain, about a question so obvious that almost nobody bothers to ask it. Why did the apple fall straight down? Why not sideways? Why not up? It took him nearly 20 years to fully answer that question. But it started right there, with one simple observation everyone else would have ignored. Newton became convinced that whatever pulled the apple down wasn't unique to apples or even to Earth. He suspected the same invisible force pulled on the moon, the planets, everything in the universe. We call that force gravity now. There was just one small issue. The math needed to prove it didn't exist yet. So Newton thought about it, shrugged, and basically said, "Fine, I'll invent the math myself." Over those same isolated years, he built the foundation of an entirely new branch of mathematics: calculus, not an improvement on something that already existed. He created it from scratch because the tools he needed simply weren't there yet. By the time he was 23, Newton had already made revolutionary discoveries in calculus, motion, gravity, and optics. And then he told almost nobody. He put it all in a drawer and left it there for 20 years because he considered it more of a hunch than a proven fact, and he wasn't ready to defend it publicly yet. Newton wasn't only obsessed with numbers on paper either. He tested things on himself, often recklessly. He once slid a blunt needle between his eye and the bone behind it, just to see what would happen to his vision. Reportedly, he saw colored rings afterward and somehow walked away with no permanent damage. Another time, he stared directly at the sun's reflection in a mirror for as long as he could physically stand it, just to study how bright light affects the eye. He went blind for 3 days. It came back, miraculously. He also spent years experimenting with alchemy, the old belief that ordinary metal could be turned into gold. Some historians think repeated exposure to mercury during these experiments left him with mild poisoning for a long stretch of his life. His obsession with light also led him to a genuinely bizarre claim for the time: that white light isn't actually white at all. It's every color of the rainbow blended together. At the time, people thought this was nonsense. Eventually, it turned into one of his most important discoveries, letting him fix a major flaw in the telescopes of the era. He built his own telescope design using mirrors instead of standard lenses, solving a color distortion problem that had frustrated astronomers for years. Reflecting telescopes based on his design are still in use today, including the basic principle behind the Hubble Space Telescope. By his late 20s, Newton had a real reputation, and with reputation came rivals. Chief among them, a sharp, ambitious scientist named Robert Hooke, one of the first people ever to describe a biological cell under a microscope. Hooke tore into Newton's theory of light publicly, and Newton, who hated criticism more than almost anything, went quiet for years afterward. Instead, he turned his attention somewhere nobody expected: theology. Roughly a quarter of everything Newton ever wrote in his life wasn't about science at all. It was about religion. He held views considered radical for his time, rejecting core beliefs most people around him accepted without question. He even used complex calculations based on biblical prophecy to estimate a date for the end of the world. His answer, the year 2060, science, Newton believed, could explain how the universe moved, It couldn't explain who set it moving in the first place. While Newton drifted toward theology, a separate chain of events was quietly pulling him back into science. An astronomer named Edmund Halley, genuinely one of the most impressive people of his era, a sea captain, mapmaker, and inventor, got into a friendly argument with two colleagues over coffee in London. The debate, why do planets travel in elliptical orbits instead of perfect circles? One of the men at that table, that same Robert Hooke, claimed he already knew the answer but refused to say it out loud, apparently just to seem impressive. I know the answer, but I'm not telling you. Just say it, man. I know, but I'm not telling you. Frustrated, Halley traveled to Cambridge, looking for someone who could actually solve it. He found Newton. He asked him directly, "What shape should a planet's orbit take?" Newton answered immediately, "An ellipse." He said he'd already proven it years earlier. Halley was floored and asked to see the proof. Newton dug through his own papers and couldn't find it. He had solved one of the biggest open questions in physics years before and then simply lost the notes in a drawer somewhere. Halley pushed him to redo the entire calculation and publish it properly this time. Newton agreed, and once he started, he didn't stop. He disappeared for 2 years, reworking and expanding everything he'd ever discovered about motion, gravity, and mathematics, determined this time to actually publish it. The result was Principia Mathematica, released in 1687. Widely considered one of the most important scientific books ever written, and at the time also one of the hardest to actually get through. Inside were Newton's 3 laws of motion, laws that are still taught in every physics classroom on the planet. The first, an object at rest stays at rest, and an object in motion stays in motion unless a force acts on it. On Earth, moving things eventually stop because of friction and gravity. Out in empty space with nothing acting against it, a moving object just keeps moving forever. The second, acceleration depends on force and mass. Push something harder, it speeds up faster. The heavier it is, the more it resists that push. Get hit by the rock, you're going flying. Get hit by someone half his size, you'll barely notice. The third, every action has an equal and opposite reaction. Hit something, and it hits back with equal force in the opposite direction. That reaction is usually what actually hurts, not the strike itself. Then came universal gravitation. Every object in the universe pulls on every other object. More mass means more pull. More distance means less pull. It's the exact same force holding the moon in orbit and pulling an apple to the ground, just working at completely different scales. Before this, most educated people already accepted that the Earth was round. Newton's laws pushed it even further. The Earth isn't a perfect sphere at all. Its own spin causes a slight bulge at the equator and flattening at the poles, exactly what his math predicted it should do. Principia made Newton one of the most respected scientists alive, but almost immediately his old rival came back for round 2. Robert Hooke publicly accused Newton of stealing a core idea, the inverse square law behind gravity, from him. Furious, Newton refused to publish the final section of his book and threatened to withhold it entirely. Once again, it took Halley to talk him down and convince him to actually finish what he'd started. Even then, the project nearly fell apart. The scientific society that promised to fund the book's printing backed out at the last minute, worried it wouldn't sell. Halley, who wasn't wealthy himself, ended up paying to publish it out of his own pocket. It became one of the most important books ever written. 2 years later, Newton was elected to Parliament. According to several historical accounts, in all his years there, he only spoke once, to ask someone to close a window because he was cold. Despite the growing fame, Newton's personal life stayed strange and difficult. In 1692, he suffered a severe nervous breakdown and stepped away from university work for 2 years entirely. During that time, he quietly kept researching optics but refused to publish any of it. The reason? He was waiting for Robert Hooke to die first. Hooke passed away in 1703. Newton took over his position at the Royal Society almost immediately, and within a year finally published the optics research he'd been sitting on for over a decade. Not long after, a new rival showed up. A mathematician named Gottfried Leibniz publicly accused Newton of stealing the concept of calculus from him. Here's the funny part. Newton, as a senior member of the Royal Society, ended up personally investigating the accusation made against himself. Shockingly, he found himself innocent. Historians today mostly agree the two men developed calculus independently around the same time, without either stealing from the other. But officially in 1712, Newton was declared its sole inventor. Newton's grudge against Hooke didn't end with his death either. Once Newton rose to power at the Royal Society, records and portraits connected to Hooke mysteriously started disappearing. To this day, historians still aren't entirely sure what Robert Hooke actually looked like. No verified portrait of him survives. Around the same time, Newton took on an unusual new job, running Britain's Royal Mint, the institution in charge of producing the country's coins. Counterfeiting was a massive problem at the time. Newton handled it the way he handled everything, with total, relentless precision. He redesigned the coins to make them far harder to fake, and personally tracked down counterfeiters, several of whom were eventually executed for their crimes. In 1705, this work earned him a knighthood. Sir Isaac Newton, not primarily for gravity, calculus, or the laws of motion, for fixing the currency. As Newton aged, he drifted further from active science and further into questions of faith, prophecy, and, unexpectedly, the stock market. In 1711, Britain launched a company designed to help pay off national debt through public stock sales. Like a lot of people at the time, Newton bought in. The stock's value shot up fast and Newton sold early, walking away with a solid profit. Then the price kept climbing. Convinced he'd left money on the table, Newton bought back in, this time investing most of what he had left. Shortly after, the bubble burst completely. The stock collapsed. Newton lost far more than he'd ever made. Even one of history's sharpest minds wasn't immune to watching a number go up and convincing himself it would never come down. Isaac Newton died in March 1727, after several days of declining health. He never married. He spent much of his life private, guarded, and quick to hold a grudge for decades if he had to. But almost everything you learned in a physics or math class traces back to him somehow. His laws of motion, the mathematics behind calculus, the basic principle behind modern telescopes. Even Einstein, centuries later, kept a portrait of Newton hanging on his wall. Late in life, in a rare moment of humility, Newton wrote to a colleague, "If I have seen further, it is by standing on the shoulders of giants." So here's the thing about that famous apple. It wasn't really the answer. It was just the moment where 20 years of quiet obsession finally had something to land on. And that, my friend, is the story of the man who looked at a falling apple and somehow ended up explaining the entire universe.